Hello again. As a continuity to Big Data Basics, today we are going to present an introduction to Hadoop Ecosystem. During this presentation, we are going to follow the following plan. First of all, we are going to present the context and the problematic under which Hadoop Ecosystem has emerged. Afterwards, we'll present Hadoop as a solution. We will discuss its evolution, and finally, we will present Hadoop Architecture along with its main components. As we can see in this slide, the traditional databases failed to support the 5 V's of data. Accordingly, we can see that the datasets became too large to the point where it is beyond the ability of typical softwares or databases tools to capture, store, manage, and analyze. Consequently, the GFS system was proposed, as we have discussed before, in order to deal with these challenges. Specifically, it has been designed to run on a large number of inexpensive servers in order to process and store data in distributed manner. To recapitulate, we can see here in this slide that the emerging challenges can be summarized in the following characteristics, which are high volume storage capacity, fast processing power, scalability and safety and security characteristics. To cover all these characteristics or challenges, Hadoop Ecosystem was proposed as a continuity to the GFS system. So let's see its definition together. Hadoop is an open source software framework for storing data and running applications on large clusters or commodity hardwares in order to provide massive storage for any kind of data, enormous processing power, and the ability to handle virtually limitless concurrent tasks or jobs. From the main challenges, we can derive Hadoop objective requirements as follows: storing and processing large volumes of data, managing and dealing with structured, semi-structured, and unstructured data, using simple programming models for processing, ensuring high scalability and availability, and using commodity hardwares which are cheap with little redundancy. Accordingly, we can enumerate in this slide the main advantages of Hadoop as follows: low costs, scalability, flexibility mechanism, high processing speed and power, fault tolerance, high throughput, and minimal network traffic. Now, let's move on to the Hadoop evolution. It all began in 2006 when Hadoop was released. Its idea was very revolutionary, storing any type of data, whether it is structured or unstructured, in a single repository, free of any limiting schema, and processing that data across computer cluster built out of commodity servers. In 2012, Hadoop 2.x series with the more stable version of Yarn was released. And in December 2017, Apache 3.00 was released. We can see that the Hadoop 3.x series was the next big milestone in the line of Hadoop releases. This version of Hadoop includes various features, enhancements, like erasure coding, the introduction of Yarn Timeline Service 2.0, and the adoption of the intra-node balancer, and so on. Therefore, these changes might increase the chances of using Hadoop by the industry. Now, let's discuss Hadoop architecture. We can see that in the Hadoop architecture there is the HDFS layer, which enables to store data in distributed manner. On the top of it we find Yarn, which is a resource manager. And in order to control access to data and metadata stored on Apache Hadoop cluster, we have Apache Sentry. On the top of it we find MapReduce, which is a parallel programming model suitable for processing very large amounts of data. We perceive on the top of it two languages, which are Apache Pig and Apache Hive. These two languages we use as MapReduce for processing. We can see here the Apache Solr, which is a search engine with the REST-like API. We have Apache Impala, which is a language that is similar to Hive, but with the more rapid processing abilities. Impala integrates with the Apache Hive Metastore database to share databases and tables between both components. On the left of it, we perceive the Apache Spark, which is a data processing framework that can quickly perform processing tasks on very large data sets. And concerning data ingestion, we have two tools. We have the Apache Flume and we have the Apache Scoop. Apache Flume is used when moving large amounts of log data from different sources to centralized data store. And when it comes to structured data stores, we use Apache Scoop. It is used when transferring bulk of data between structured data stores, which are the relational databases, and the Hadoop ecosystem. In short, we can enumerate the three main components of Hadoop architecture in three components, which are the HDFS for storage, we have the Yarn for resource management, and lastly, we have the MapReduce for processing. Finally, we recapitulate with what we have seen before. Throughout this presentation, we have seen how data reached the point where it was impossible to process it and store it in traditional databases. We have presented Hadoop as a solution to overcome these challenges. Afterwards, we have seen Hadoop advantages and how it allows processing and storing large volumes of data in distributed manner. We have also presented Hadoop architecture along with its main components and how they are used to ensure data storage and processing in an effective manner. Now we have come to the end of this course, so if you have any question, feel free to put it in the comment section, and we will be glad to reply to it as soon as possible.